Good morning, students. In the last class, we have started the chapter of understanding quadrilaterals, and in that we have covered few basic terms like what is simple curve, what is a closed curve, open curve, polygon, concave, convex polygon. And in this chapter, we are continuing from classification of polygon. That means what are the different types of polygon. Now the polygon will be classified based on their size. For example, I have 3 sides. It will be called as triangle. I have 4 sides. It will be called as quadrilateral. Now I am sure you might be confused with if it is a quadrilateral, what are squares, rectangles. Now the classification of a quadrilateral based on their properties will be square, rectangle, trapezium, parallelogram, kite. So about this in detail we will talk later. This third one is when you have a line segment 5 in a closed curve, then it is called as pentagon. Similarly, 6 will be called as hexagon. 7 will be heptagon, 8 will be octagon, 9 will be nonagon, and 10 will be decagon. Now, if I have n sides, if I have n number of sides, it will be called as n-gon. Okay? Number of sides is n, then it will be called as n-gon. Now I'm sure you should have understood what are the different types of polygons which we have. After that, diagonal. What is diagonal now? Now if I have a diagonal like this is a rectangle, or you can call it as a quadrilateral. We know that this is called as a diagonal. Now how do you define a diagonal? Diagonal is nothing but joining of non-consecutive vertices. Joining of non-consecutive vertices. That means this is one vertex B, C, D. Now what is a vertex and vertices? Vertex is a singular, vertices is a plural. Now this is one vertex, this is the second, this is the third, this is the fourth. Now as per the definition, joining of non-consecutive means it is not a consecutive. Now if this is the first one, this will be the consecutive. So this will be the non-consecutive. So you join these two, it will become a diagonal. If I take this point, this is the consecutive, this will be the non-consecutive. Now BD and DC are the diagonals. Let's try in a different polygon. Now what do you call this? How many sides we have here? 1, 2, 3, 4, 5. A, B, C, D, E. 5 sides are called as pentagon. Now how do we draw the diagonal here? Take first point A, which is the non-consecutive, leaving the first one. This will be the non-consecutive. This is the first diagonal. Now take the second point, leave this point, join this one. This is the diagonal. Now go back to this one. If you leave this one, you're joining the third one. Now come back to here. If you come here, leave this point, join. Come here, leave this point. So these are the triangles. This is 1, 2, 3, 4. That means in this we get 4 triangles. Okay, I want you to try in a different polygon. That is hexagon, heptagon. Just check how many diagonals you get. Now the next one is angle sum property of polygon. Angle sum property of a polygon. What does this mean? That means in a polygon, inside, what is the interior? If you add all the angles, how much we get? In our previous classes, we know that if I have a triangle, when I add all these angles, I will get 180 degrees. We already learned this one. So based on this concept, we have to derive. Let's do one, right? What is this? A, B, C. This is a quadrilateral. Do we know how much we get when we add all the angles inside the quadrilateral? Say for example, this angle, this angle, this angle, this angle, which is angle A plus angle B plus angle C plus angle D. How much we get? How do we do this? Now, you can make this into two triangles. If I make this as two triangles, let me take this as angle 1, 2, 3, 4, 5, 6. Because we have two triangles here. So total number of angles will be 6. Can I write angle 1 in triangle ADC? ADC. How many angles we have? 2, 1, 6. Angle 2 plus angle 1 plus angle 6 is 180 degree. We know this, right? Take the second triangle. That is in triangle ABC. Angle 3, angle 4, angle 5. Angle 3 plus angle 4 plus angle 5 is 180 degree. Correct. Angle 4. We get angle 2 plus angle 3 plus angle 1 plus angle 4 plus angle 6 plus angle 5 is equal to, how much is this? Can I write 2 into 180 degree? Is this correct? I have 180 and 180. 2 into 180. Now here, what is angle 2 plus angle 3? Angle A. What is angle 1? Angle B. What is angle 6 and 5? This angle C. Angle 4 is B. We get 360. So what is the answer for this? When we add all the angles in a quadrilateral, we get 360 degrees. Quadrilateral. We get 360 degrees. Now here, how many sides we have in a quadrilateral? N is equal to how much? 4, right? Can I write 2 into 180 degrees? 360 is 2 into 180 degrees. N is equal to 4. Here, 2 into triangle. That means in one quadrilateral, we get 2 triangles. Correct? Now here I have 4 sides, right? Can I write 4 as 4 minus minus 2 into 180 degrees. 4 minus 2. 4 is n. 2 I noted as 4 minus 2. Now replace 4 as n. You get n minus 2 into 180 degrees. Now what do you understand by this is sum of the interior angles of a polygon of n sides will always be equal to n minus 2 into 180 degrees. This is the formula. Now, how do we check whatever we have derived is correct or not? Now here, in a triangle, what is the number of sides? 3, right? Now what is the sum of the angles of a polygon? Sum of the angles of a polygon n minus 2 into 180 degrees. This is the formula. Now let's try for triangle. For a triangle, what is number of sides? 3, right? Put this value here. You get 3 minus 2 into 180, which is nothing but 1 into 180, which is 180 degrees. So for the triangle it is 180, which we already know. If you apply same thing for a quadrilateral, 4, right? This 4, this 4, this 2, you get here 360. Similarly, you can find for pentagon, hexagon, everything you can find. Okay, now we are doing sum of the exterior angle of any polygon. Now we have already learned that the sum of the interior angles of any polygon is n minus 2 into 180 degrees. Now they are asking about the exterior angle. Now if you take a quadrilateral, this is A, B, C, D. These are the interior angles. These are the 4 interior angles. When I add all the interior angles, how much do I get? 360 degree. Because we have already done this in the previous session. The sum of the interior angles of a quadrilateral is 360 degrees. Now, which are the exterior angles in this? Now, just extend the line. These are the exterior angles. Here, 5, 6, 7, 8. The angles which are outside are called exteriors. Now, how do we find how much we get when we add angle 5, angle 6, angle 7, and angle 8? That we have to find. Now, what are these two angles called? Linear pair. Some of the linear pairs are always 180 degree. When you add, I get 180. When I add these two 180, these two 180, and these two 180. Now, angle 1, see here, angle 1 plus angle 5 is 180, correct? Now, can I write angle 1 as 5 comes here? 180 minus angle 5, is this correct? Same thing you're writing here, 180 minus angle 5. Similarly, 180 minus angle 6. Similarly, 180 minus angle 7. Similarly, 180 minus angle 8 is equal to 360 degree. Correct? How many 180s we have? 1, 2, 3, 4. 4 into 180 minus angle 5 plus angle 6 plus angle 7 plus angle 8 is equal to 360. Now what are these exterior angles, right? Shift this side, this side. You get, how much is this? 720 minus 360 is equal to angle 5 plus angle 6 plus angle 7 plus angle 8, which is nothing but sum of exterior angles. 720 minus 360 is 360. So how much do you get when you add all the exterior angles? When you add all the exterior angles, you get 360 degree. And this is not only for the quadrilateral, it is for any polygon. So in this session, we learned two things. The first one is sum of interior angles of any polygon is n minus 2 into 180 degree. Sum of exterior angle of any polygon is 360 degree. Now whatever the 360 which we got, if you try for hexagon or a decagon, it does not depend on number of sides. Okay. However, whichever polygon you take, you will get 360 degree. Okay. Now these two are crucial, very important formula which we are doing for the next coming problems. So I want everyone to remember this. If you have any confusions, we will be that an interactive session. Thank you so much. Have a good day.